Recording.
So now, why do we need BGP? First of all, see, normally your dynamic routing protocol has two variants. One is called IGP, Interior Gateway Protocol. Second is EGP, Exterior Gateway Protocol. Now, EGP has two flavors. One is called IBGP. Second one is called EBGP. IBGP. IBGP expands to Interior Border Gateway Protocol. EBGP expands to Exterior Border Gateway Protocol. And the main difference between IBGP and EBGP is that IBGP is used to connect non-directly connected routers within one AS. So within one AS, if you want to connect R1 and R10, we use IBGP. EBGP we use whenever you want to connect two different autonomous system or two different domains. For example, it is ISP1, it is ISP2, and you are trying to connect R1 and this router, R2 router. In this case, we use EBGP. Once again, IBGP is used within the cloud to connect non-directly connected routers. EBGP is used between two different clouds. Now, BGP is a EGP standardized path vector routing protocol. BGP was developed to run between two autonomous systems. From the perspective of BGP, AS. Now, what is autonomous system? Autonomous system is nothing but collection of routers and other networking devices, which is managed under single organization control. Now, BGP advertise incremental updates only, not the entire routing table. Now, as I told you, BGP has two variants. One is called IBGP, second one is called EBGP. Now, when you talk about autonomous system numbers, there are two variants. One is called 2-byte autonomous system. Second is called 4-byte autonomous system. When I say 2-byte means is equal to 16-bit, which is equal to the power of 16. That goes around 65,536. So if I'm using a number between 0 to 65,535, I can tell I'm using a 2-byte AS number. And we also have 4-byte AS number, which comes under RFC 4893, where we can use up to 4294 ... Now coming to this one, which is currently we are using now, we have two different types. One is called public ASNs, second is called private ASNs. Public ASNs, as the name says, this AS numbers can be globally unique. Sorry, will be globally unique and can be routable to the internet. Now, private ASNs ki baat kare, it will be within the cloud only. It will not go beyond the cloud. Now, how do we configure BGP? It's very, very simple, like your OSPF and all, right? So we have R1 router, R2 router, and how to configure BGP? Just go to configure terminal and type router BGP AS number and provide the neighbor IP, remote AS, and the remote AS number. See, unlike your OSPF or any other IGP, here we have to mention the neighbor. Why? Why? Because here neighbors are not automatically found. So I normally BGP enabled router will not send any sort of multicast packets to a multicast destination network or IP address to find out who is my neighbor. They don't do that. They don't do that. They do that. So which means we have to manually find out who is my neighbor. Now, Till now, any doubts or question, guys? Please ask me. Yeah. Let's do the lab on basic lab on BGP. I'll just show you how to connect two routers and how to enable BGP between them. So this side I'm going to configure IP address 10.001, neighbor end 10.002, and I'll show you in one diagram itself configuring EBGP first, sorry, IBGP first, then EBGP both. So when I say IBGP means both belong to same autonomous system. So his AS number will be 100 and his NAS number will also be 100. Let's configure BGP. Router BGP 100, neighbor IP address, type remote AS
100.
and type 100. Sorry?
100.
Yeah. So here also router BGP 100, neighbor 10.001. Yes, 100. See, if I am typing my AS number and remote AS number both as same number, which means
IBGP.
it's called IBGP. Let's run a verification command. Show IP BGP summary. Here you can see my BGP came up without any problem. So in this output, you can see my neighbor IP address, which version I'm using. I told we have two versions of AS numbers, right? Version 4 and version 6. Sorry, version, yeah, version, not version, it's byte, 2 byte and 4 byte, right? So it's a version 4. Now we have AS number, which is my AS number, sorry, neighbor AS number, and here is the main information. This column or this row, whatever it's called, it gives you the number of IPs I am learning from neighbor. So as of now, here you see 0, right? 0 means I am not learning any IP address from neighbor. Let's try to learn an IP address from neighbor. How do we normally advertise IP address? Using network command. So I'll go to R2. I'll create an IP address here. I'll create loopback IP address. Interface loopback 0. IP address. Done. That's all. Router BGP 100. If neighbor is sorry, network command. Network 2.0.0.0 mask 255.0.0. That's it. Now I'm advertising this prefix to my neighbor. So I'll come to R1. If I refresh again, here you can see 1. Why? Because I am learning one IP from neighbor. Do show history. Now here is the command which I used to configure everything. You guys note it down? Please note it down now. So far, doubts?
No, sir.
Now, how do we enable EBGP? EBGP means this AS number will become something else. I'll give it as maybe 200. Same formula, same command. Just type neighbor IP remote AS 200. Here you will get router BGP 200, neighbor IP 200. So when I say EBGP means just the numbers will vary. Rest everything is same. Okay. Next thing, BGP route advertisement. Now how can we advertise route to my neighbor using BGP? See, to advertise neighbor IP using BGP, just now I told you guys, use network command. We use network command to advertise any prefix with a defined subnet mask value. Now, how do I verify whether I am advertising it or not? See, BGP has a feature that helps us in identifying whether I am sending the prefix or not. I can check whether R2 is sending the 1111 or not. I can check in R1 whether am I receiving 1111 or not. So this output, what you saw, this show IP BGP summary output, it just shows you I receive one prefix, but which prefix I'm receiving? To see that, let's go to R2 and check what am I advertising. The command is show IP BGP neighbor IP advertise routes. This will give you details of what IP am I advertising. Here you can see it clearly shows you I'm advertising 2.0.0.0 network IP to R1. Now I can go to R1. I can check what am I receiving, but this command will not work. See, show IP BGP neighbor 10.0.0.2 received routes. This command will not work because you have to configure inbound soft reconfiguration, because see, every time my routers will not show me the received routes because it consumes some amount of CPU, because of which I have to exclusively enable this command. It's a very simple command. Go to configure terminal, go to router BGP 100 and type neighbor IP soft reconfiguration inbound. That's all. If you enable this command, now I can see what am I receiving. Now the inbound table you can see easily. Now this is a command to verify what am I sending, what am I receiving.
Sir, path I, what is denote here? Path I, last column.
Path I shows me. See, there are two types of value here to show. One will be I, one will call question mark. I means this IP what I'm learning via a network statement. So in R2, I use network statement, right, to advertise a prefix, which means this is a BGP originated prefix. That's what he believes. Or through my network statement, I learned it. And instead of using network statement, if I tell redistribute, I can also advertise a prefix using redistribute command, right? I can go and say router BGP 100. I can type redistribute connected or redistribute something. If I redistribute, then it will show question mark. Let's do that. I'll go to R2, configure terminal, router BGP 100. I have to change this value again. confusing me itself. 100. No network 2.000 mask 255.0.0.0. Now if I just go back to R1, if I try to see, I'm not learning any prefix. It shows 0 at last, right? Now if I advertise is using redistribute connected, which also included the loopback IPs. Now if I go and check, obviously when I say redistribute connected, it will advertise my interface IP also, that's fine. But if I go and check received routes, it shows question mark. Why question mark? Because now I'm learning the prefix through a redistribute command. Understood?
Vishnu, can you repeat this? I think I got confused.
If you see, if you advertise a prefix using a network command, it will show you in the neighbor I, the path. It will show
Okay.
you I. If you advertise a prefix using redistribute command, if I redistribute a loopback IP instead of using network statement, it will show you question mark.
Okay.
Let's talk about the BGP path attributes. Okay, this will be confusing as of now, but just remember the names alone. I'll explain it later. So BGP path attributes means with each network or with each prefix I'm advertising to a neighbor, BGP also advertise some additional things just to give him more clarity on which path is best path, or just to give us an option of choosing the right path. So when we talk about attributes, we have well-known mandatory, well-known discretionary, optional transitive, and optional non-transitive. Well-known mandatory means all the BGP enabled routers should understand this attribute, and also these attributes should flow to my neighbor by default. There's no option of not sending it or not understanding it. Second is well-known discretionary. Well-known discretionary means this attribute may or may not be included with the prefix advertisement, but all the BGP routers are aware of this particular attribute called local preference. Optional transitive means my BGP enabled routers may or may not be aware of this attribute, which is called community, but it can be sent to my neighbors. Non-transitive means this attribute may not be known by all my BGP enabled routers, but also it cannot be sent to my neighbors. For example, cluster list. See, the actual attributes are them only. We are grouping them into categories, 4 categories or 4 path attributes. So well-known mandatory, well-known discretionary, optional transitive, optional non-transitive. Now even if you see my output, right, the show BGP output, here you can see some attributes which are coming. So here we have metric, local preference, weight, path. These are called attributes. Even next stop is also called attributes. So by using these values, we can manipulate the path selection actually. And one more information. So you guys know that in OSPF, we carry all the IPs in the form of LSAs, links in advertisement, right? Which carries all the IP address to my neighbor. In BGP, we use NLRI, network layer reachability information. NLRI is used to carry the BGP updates to my neighbor. Now, how do I show you that? I can show using Wireshark. Let's start the capture here. and advertise one IP address. Let's go to R2. I already enabled reducible content, right? Which means if I try to enable a loopback IP, it automatically will send it. So let's configure loopback IP. Interface loopback 1 IP address. Now you'll see an update going. If you click on update message, click on this under NLRI, you'll see the IP address. Now who is carrying the IP addresses in BGP?
NLR.
NLRI.
NLRI carries. In OSPF,
LSA.
LSA.
correct. Okay, that's what the information I want to share. The next is your loop prevention mechanism. In OSPF, do we have any loop prevention mechanism? If somebody asks you a question in OSPF, what is the loop prevention mechanism we are using? In OSPF, we don't use any loop prevention mechanism at all because OSPF have something called topology table. So because I'm having topology table, I no need to have a loop prevention mechanism. Now what is topology basically? Topology is network diagram. So OSPF, with the help of topology diagram, it can imagine the entire network diagram itself, which means how they are connected. Like I'm drawing a diagram, right? So if you enable OSPF between them, OSPF will be aware, this OSPF on R99 will be aware of how they are connected. What is the link cost between them? Where is R21 and 22 connected? How they are connected? How his neighbor is? Who is his neighbor? Because of topology table information, it has an entire kind of GPS map. Now you tell me, if you have a GPS map on your phone or your hand, will you looping same location again and again? Normally, geographically, no, right? Because I know where I'm crossing. Because OSPF has topology table, it doesn't need a loop prevention mechanism at all. Loop can never gonna happen. But in BGPs, we don't have such options. So we have mechanisms. For example, in eBGP, my AS number, if a BGP enabled router receives a network or IP address or subnet from a neighbor, and in that neighbor receiving subnet, if it sees its own AS number in it, that can simply discarded. See, as I told you, AS number or AS path value is mandatory, right? Here, when AS path is mandatory, which means it will include the all path while traveling. So here, I am sharing a prefix, this prefix to my neighbor with AS number of 100, which is my AS number. When the same prefix gets shared by AS 200, it gets added. The AS path will be created. Again, it's getting added 400. Again, 300 getting added. When it try to go back to the same AS 100, it sees, the AS sees that the receiving AS number is receiving value is also having my AS number. This could be a potential loop. So I'll simply discard the update. This is the loop prevention mechanism we have in eBGP. Now coming to IBGP, it says an IBGP learned route will not be sent to another IBGP router. It's very simple. So if you have a big cloud, the IBGP loop prevention mechanism says, I'm having R1 router. It's learning a prefix from somewhere in the internet or somewhere outside my AS. And I have a lot of routers like this. Imagine I'm learning 1.1. Here you have 1.1.1.1. This guy is learning the same 1.1.1.1 prefix from eBGP. This can be sent to my IBGP, but the same IP will not be sent to my IBGP neighbor. So an IBGP learned route will not be sent to another IBGP router. Because if I send this may lead and flow, what if I have routers connected like this also? There is a high chance I connect routers like this just because of load balance or something like that. this can cause a loop, right? If an IBGP learned route is sent to another IBGP router, which means it can flow entirely like this, it can cause a network loop or layer 3 loop. So we avoid it. We don't send an IBGP learned route to another IBGP router. Just avoid layer 2 loops. But obviously, you have to learn it in future. All IBGP routers should be aware of a prefix and all to get reachability. For that, we use a concept called RR, route reflector. We'll talk about that later. So far, if you guys have any question, please ask me.
सर वो पाथ एट्रीब्यूट समझ में नहीं आया जो सेकंड लास्ट स्लाइड थी ना, 4 उसमें थे
समझ नहीं आएगा अभी। पाथ एट्रीब्यूट हम पढ़ेंगे इसके बाद वापस। वो जस्ट इंट्रो था।
ठीक है सर, ओके।
हाँ, वो उसके बाद हम पढ़ेंगे ना और एक बार, तब समझ में आ जाएगा वो एक बार। अभी तो बस नाम खाली याद रखना, वेल नोन मैंडेटरी, वेल नोन डिक्शनरी, ऑप्शन ट्रांजिटिव एंड ऑप्शन नॉन ट्रांजिटिव। Just give me a break, guys. I'll come back in 5 minutes. Let's talk about some more information about the BGP, like inter-router communication. As I told you, BGP does not use any sort of multicast IPs to become a neighbor, so it cannot discover the neighbors manually or dynamically, automatically. So we need to manually configure who is my neighbor. And BGP uses TCP port number 179 to communicate with other routers. So whenever I want to form neighborship, it forms over the TCP protocol port number 179. BGP supports fragmentation, sequencing, reliability, DF, and rely on path MTU discovery. So when I say fragmentation MTU, you must be thinking about OSPF also. Like when you have 2 routers, when I try to form OSPF neighborship, if they have a mismatched MTU value, they're stuck in Xstart state. Why? Because after Xstart state, your DBD packets need to be exchanged or need to be compared. For comparing DBDs, I have to make sure both are having either they should have same MTU, because OSPF does not support fragmentation. OSPF does not support fragmentation. So when I say OSPF does not support fragmentation, if you have mismatched MTU value, then DBD exchange will not happen properly. That's why they just stuck in Xstart state. But in BGP, it is not like that. It supports fragmentation, which means even though if you have a mismatched MTU, they can still become neighbors and share the updates. Now, some more information about BGP is that BGP's IBGP ID value is 200 and EBGP ID value is 20. Similar to that, IBGP TTL is 255, EBGP time to live is 1. Okay, so let's talk about eBGP. Now, eBGP peering are core component of the BGP on the internet. So eBGP involves exchange of network prefixes between two different autonomous systems. Now coming to time delay value of eBGP, which is 1 by default, which means what? I can form eBGP neighborship within the immediate neighbors only. I cannot form eBGP neighbors between R1 and R3. Between them, eBGP neighbors we cannot form, but however, I can form iBGP neighbors. Now, to overcome this problem of having time delay value as 1 in eBGP, we use a command called eBGP multi-hop, which help us in forming neighborship between R1 and R3 also. The command is eBGP multi-hop. And I can give a time delay value of 2 or 3 or 4, whatever I want. And normally, the advertising router modifies the BGP next hop address to the IP address sourcing the BGP connection. What I meant to say here, imagine R5 is sending out an update to R4. Maybe a prefix I have, R5 has loopback IP of maybe 5.5.5.5. R5 is sending the update to R4, which means R4 will have next hop IP as this interface IP address, right? Maybe it is 45.005. This will be the next hop IP to reach 5555. And the same R4, when shares the same update to my neighbor, for R3, what will be the next hop IP address to reach 5555? Can someone tell me? When R4 shares same update to R3, for R3, what will be the next hop IP to reach 5555? It was a simple question actually. It should be R4, right? It should be R4 interface. However, BGP will show 45.005 as the next hop IP. So the next hop will not be changed basically. So whenever an eBGP router is sending out an update to another router, the same router shares an update to my own iBGP, the next hop IP will not change. And also in eBGP, the advertising router prepends the ASN to the existing AS path variable, which means whenever a BGP enabled, the prefix flows from one AS to other AS, they always prepend or add its own AS number before sharing to neighbor. So when the IP goes from this guy company 3 to company 2, it goes with 65,300 AS number. When it is going from company 2 to company 1, the AS number will be added the path. Then 65,200. So I will keep on adding my own AS numbers in the AS path value or variable. And the receiving router makes sure or verifies that AS path variable does not contain its own AS to avoid loops. And EBG configuration is a ditto Xerox or same, except the different in the AS number. Now coming to the BGP messages, we have 4 types. We have open message, update, notification, and keep alive. Open message means it is used to establish the BGP adjacencies. It consists of BGP version number. It consists of BGP hold down timer, BGP identifier, nothing but BGP router ID. So these things will be exchanged or will be compared in the open message mainly. Then we have keep alive message, which flows every 60 seconds once to maintain the BGP neighborship, and the BGP does not rely on TCP connection for keep alive. Okay, so BGP initially uses TCP on port number 179, but keep alive will flow as it is. Let's see this on the lab. So let me check, is it right or wrong? No, it's wrong. It's wrong. So the statement is wrong, what I wrote there. BGP uses keep alive also uses TCP only on port number 179. Let me change it. Does not need, does rely on. Does rely on TCP connection to ensure, yeah. TCP, even the port number is same, 179. Next, your update message. As I told you, update message carries the actual IP address, or I can say NLRI, network layer reachability information. Then you have notification. A notification message is sent whenever there is an error is detected. See, a lot of people think notification is just for information and all. Not like that. Whenever you have an issue or error in my network, we use notification message to be sent. Now coming to the BGP neighbor states, we have idle, connect, open send, open confirm, establish, and update. Idle means BGP is enabled, but there's no connection between them. Connect means when he tried to form a three-way handshake, the SYNAC and ACK on port number 179. So TCP three-way handshake happens. At that time, it shows connect. Open send means when I send an open message to my neighbor. Open confirm means when the neighbor guy confirms that he received an open message. Now here you can see after open confirm, it goes to established state, which means they are fully formed neighborship. After established state only, the actual update packet happens. Because see, before forming neighborship, I cannot exchange anything to my neighbor, right? So here, your update happens after getting established the connection. In update packet, they share the BGP routing informations. So these are the states. If you have any issue in the TCP three-way handshake in connect state, the BGP neighborship is stuck in active state. When I say active means it is not actively working. It's just actively working to actively trying to form three-way handshake. This diagram will give you more clarity on this. So idle, connect. In case TCP handshake is unsuccessful, I'll go to active state. I'll try to again form, try to form again. If it is good, then just go with open send, open confirm, establish message.